Okay, in the last sessions, we learned how to overload operator as global functions defined outside of the class. In these sessions, we will look at overloading operators as member functions. The operator can be overloaded as member functions. In the last sessions, when we are overloading binary operators from outside of the class, we use two arguments. But if we overload the binary operator as member functions, we only need one parameters, not two. The calling objects served as the first parameters. So for example, if plus operator is overloaded as member functions, then in the expressions cost plus text here, the variable cost is the calling objects and the text is the single argument to the overload plus operators. You can think it as like this form. Cost is calling objects, and using these dot operators, we invoke the plus overloaded plus operators and passes the text as a first argument to these overloaded plus operators functions. And this is how you declare the overloaded plus operators when you are defining as a member functions. There is only one argument here. The first argument, which is cost, is passed as this pointer of these functions, and this text object is passed as a first argument here. So there's just one argument. So that is the big difference between overloading operators as a member function and non-member functions. The number of parameters are different. So we can overload operators using whether member functions or global functions. So which method is better? As shown in these slides, many C++ experts overload operator as a member functions because it is more in the spirit of object-oriented programming language. And if you overload operator as a member functions, you could directly access private members of that class. In the last sessions, because we overloaded operator outside from the class, that overloaded operator function could not directly access the private members, so we used the accessor and mutator functions. But if we define, if we overload operator as a member functions, you don't need to use an accessor and mutator function. You can just directly access the private members. So it is more efficient because there is no function calls. So it is recommended that you overload operator as a member functions. You can also overload function call operators. So this is function call operators. If you overloaded it, you can use objects of the class as if it or a functions. So if we look at this example, an object is a object of a class type. If you overloaded function call operators, you can use objects like functions as shown in this line. So this is objects, but you are using it as functions. This line will invoke the overloaded function call operators with an argument for it too. Note that you can define several overloaded versions of the function call operator so that it can receive more than one argument. So this is function call operators. And this is a logical and logical or and comma operators. You can also overload it logical and logical or and comma operators. And they work for the Boolean type. But this logical and logical or operators uses the short circuit evaluations that we learned in the previous week. And the comma operators guarantees left to right evaluations. These are the things that most programmers already knows. So, and they think that these properties, the short circuit evaluations and left to right evaluations, are guaranteed by these operators. So they will develop the code based on these guarantees. But if you overload logical and logical or and comma operators, no such guarantee is given, and it may not be the most programmers' expectations. So that will lead to the unexpected errors or behaviors from the program. So generally, you should not overload these three operators. If you have to overload these three operators, you must be aware of these short circuit evaluations and left to right evaluations. You must be aware of these guarantees when you're overloading these three operators. But generally, it is more safe not to overload these operators. Okay, let's look at the demo code for overloading operator as a member functions. This demo code also has a class name money, and now we are making overload minus operator overloaded as a member functions, and we are also overloading the function call operators. Here we have two function overloaded two function call operators. One received one argument, the second one received the two arguments. And just like a previous demo code, it has a two private member variable here. And this is the constructor, and this is the accessor. Exactly same as previous demo code. And this is the definitions of minus operators. Note that there is no argument here. In the previous demo code, we have one argument receiving the objects of class type money, but because we are now making as a member functions shown here, we do not need argument here. And the another difference is that we are not using get dollars and get cent accessor functions. Because these are the member functions, we could directly access the private member variable like this one. So there's no function call, unlike the previous demo code, which is more efficient. And we are overloading function call operators. This one received one argument. It just received the dollar and set the dollars to this value. And the second version of the function call operators receive two int type of values and uses the first value to store the dollars and use the second value to store the cents. And this is the main functions. Inside of this main function, you first create one object and print the dollar and cents. And here you are invoking these negations, minus operators, overloading minus operators. And this newly created object will be stored in M2 here, and it prints the dollar and cents here. And then it invokes the overloaded function call operators for the first arguments and for the two arguments. This one is calling one argument versions of overloaded function call, so which is this one, and this one will call this one because it passes two arguments. So let's compile this program and run it. Not this one. So if we run this program, it first prints $10 and cent 9 because of this line. We are creating objects using 10 and 9. So because $10 is 10, 9, cent is 9. And because of this one, we are just changing the value to the negative value. So now the 10 is changed to negative 10, 9 is changed to negative 9. Now we are using the first object to invoke the overloaded function call operators by passing one argument. So this will be called. So using these 20 values, it updates the dollars. So this one, so previously dollar was 10, but because of this overloaded function call operator, dollars updates to 90. And cent remains same because this does not change the cent value. And this one is also function call. This one also invoked the overloaded function call operator with a two arguments. So this one will be invoked, and it uses the first argument to set the dollars and second argument to set the cents. So dollar is set to 5 and cent is set to 50. So that is the reason why this line prints $5 and send 50. So this is how you overloaded operators as a member functions. By making it as a member functions, you can directly access the private members like this. And note that there is no arguments here. If you do not make this as a member function, so if you define this as a standalone function, you have to pass one argument. And you can also overload function call operators, this one like this. You can define multiple versions of these overloaded function call operators. If you do that, you can invoke this overloaded function call operator with a different number of parameters, like this example. Okay, that's it for these sessions. See you in the following sessions.